Greetings to everyone. I'm Sai Karan from IST Trivandrum. I'm a BTech dissertation student in IST, currently pursuing BTech final year in IST. I'm currently co-guided by Dr. B.S. Manoj from IIST and Dr. Venkatesh Prasad from TU Dec, Netherlands, in the research topic of satellite IoT, where we are trying to build a Debrinet platform for inter-satellite communication, where we are using a lightweight satellite software-defined network to smartly connect the satellites among each other and make the data transfer more efficient than other traditional satellite networks. Debrinet is a concept introduced by IAST SysNet Lab, where we use PSLV stage 4 of the rocket as a satellite system, and many such PSLV stage 4 PSLV stage 4 uh, modules will be combined to use as a satellite constellation and form a continuous connection from ground station to end user via the onboard units of PSLV stage 4. Here we can see the Debrinet inter-spacecraft network representation, where ground station and end user devices are always connected through some PS4 onboard system, uh, where the data transfer will be very efficient, and the data transfer will also be happening in the shortest path available. Here we can see the payload of our payload in PSLV stage 4, where the bottom right corner of the stage 4 is given for us to install our payload. The project is a continuous work of previous continuous work done by IAST System Networks Lab in Avionics Department. Uh, Here we are developing a new payload for a 1 unit CubeSat, which can also be put in PSLV stage 4. The CubeSat which will be used for the project will be a body molded CubeSat, where solar cells that power the satellite will be molded on 4 or 5 faces of the satellite. The hardware components of the system will include an onboard unit, a ground station, and an end user, where the onboard unit will be the satellite payload that acts as a onboard computing module. But the onboard computing module will have very low computation capabilities. So we propose a lightweight defined software defined network to meet the low computational requirement of the onboard computer. The ground station will act as a control plane of the proposed Debrinet, where we know that software-defined network will have a control plane and a data plane separated. And also the ground station will collect all the sensor data and create flow routes to create a routing between end user and ground station. When it comes to end user devices, they are the ground segment nodes that transfer sensor data to any of the nearby networking payloads through inter debris links, or we can say inter satellite links, where it is relayed to the ground station, which subsequently relays the data accordingly. Here we can see the system architecture, the way the data flows. Here controller creates control packets which define the path of the data in the shortest route possible, which is the shortest route from ground station to end user through the onboard units. The prototype of the hardware which is proposed for the project is a Raspberry Pi 0W as a computing module, and a LoRa module, a LoRa device as a transceiver module, and a real-time clock IC and a watchdog timer IC will also be present in the onboard unit. I would like to convey my thanks to Dr. B.S. Manoj and Dr. Venkatesh Prasad for giving me this opportunity to participate in IST TU Dev MOU. I'm very much benefiting from this MOU. So I would like to thank our both the professors and IAST and TU Dev. Thank you.